Good morning from the Civil Engineering National Laboratory in Lisbon, Portugal. It's a pleasure to be with you all. This morning I will share with you, based on the achievements of the Horizon 2020 Piano project by my colleague Elena Giusta from the Italian National Institute for Environment Protection and Research in ISPRA, Rome, and myself, we will be talking about two different subjects on piano. Key lessons learned from the Portuguese participation in H2020 Piano project, and from this we'll highlight piano technology, water innovations and strategic research and innovation agenda, the SRIA, for China-Europe cooperation. My name is João Paulo Lobo Ferreira. I'm in the board of directors of LANEC, and we have been with several other partners from Europe and from China, 10 in each side, dealing with policies, innovation, and network for enhancing opportunities for China-Europe water cooperation. This is being doing. We have been done this in cooperation with the China-Europe Water Platform. So we have different work package in piano, and one of them is precisely dissemination. So this presentation today, about half an hour, will be sharing of technological solutions. And we are willing to do a wrap-up of what we have presented in several conferences, as in here in the Citizen Observatories for Water Management in Venice, Italy in 2016, plus others. But a little bit before starting, I would like to have a small introduction to why are we doing this. In 1998, the European Commission, Professor Tilak Viegas, invited myself on behalf of the European Commission to organize a meeting in Beijing, as a matter of fact in the Sheraton in Beijing, so to see why we are developing projects, and if these projects, for instance, is in Nanjing, nearby in Shanghai, we don't know. Where are the bottlenecks? Why can't we further disseminate the achievements gathered in those European Union-sponsored projects? So we have launched that conference, about 100 people, with 30 ongoing past and proposals, projects, so future projects at that time. And we were discussing the European, the Chinese, and other invited participants. Where are the bottlenecks we do to increase our dissemination? In 2004, it was organized, we organized a major conference, hundreds of people in Changsha. And then it was a large step forward, making Europe and China closer in research and water resource development. From this Changsha meeting or conference, we had a declaration, Changsha Declaration, saying that we should launch projects, coordination actions, etc., that would be able to have an umbrella overview of what is going on. A lot is going on, not only in China with European Union, the projects, but also bilateral by the member states. So we launched and we won. It was BRGM coordinating in France, LANEC, Ministry of Science and Technology in China, Vietnam, plus other partners, ASEM WaterNet. So that was a large action that was launched, and by the end it was also seen that something stronger on the actors level should be developed. As a matter of fact, it was materialized in 2012. The Danish Minister Ida Auken and the Portuguese Minister of Environment Cristas launched and signed with the Chinese counterparts the EU-China Water Platform. So the EU-China Water Platform has three pillars: One is institutional, so the different member states and China develop different types of thematics, forests, water resources, etc. And we have two extra peers in this China Europe Water Platform. It's research and partnership. That's it, the society. So research is precisely at this moment the Piano project. Of course, several other projects have been launched, but this one was made in the call of the Horizon 2020. So it is the only project that was winning that call. So Piano project and China Europe Water Platform are working quite close. So Piano, as I said before, policy innovation and network for enhancing opportunities for China Europe water cooperation, has different types of scopes. Of course, the thematic of cooperation is huge, is vast, and then we had to select different topics to be addressed in relation, of course, with the China Europe Water Platform, with the Chinese government, and of course with the aims of the cooperation from Europe, so European Commission. We have selected 5 thematics. That's water for agriculture, urban water, industrial water, water resources management and flood control, and water for energy. So those are the basic aspects that we would like to develop. As I was saying before, we have about 10 European partners. BOKU, University of Natural Resources and Life Science in Vienna, is coordinating, but we have the Technical University of Denmark in Copenhagen, and International Office de l'Eau in France, the Italian National Institute for Environment Protection and Research, ISPRA, Civil Engineering National Laboratory, where we are at this moment precisely, Stockholm International Water Institute. They have the Stockholm International Water Week, and we have presented also the achievements of Piano there this year and last year too. Atkins, European Water Association, and finally European Union Chamber of Commerce in China. In China, the partners are sponsored not by the Horizon 2020 project, but by program, but by Chinese money. So we have Beijing University, the Chinese Academy of Science, Environmental Planning, Research, Environment, Science, etc., China Academy of Science, China Institute of Water Resources, Hydropower. So a lot of know-how is available in those institutions. We would like, focusing in these 5 thematics, to strengthen and expand the existing network of China Europe Water Platform to cover all actors relevant for cooperation between China and Europe in water research and innovation domain. Identification of European technology, water innovation, and areas to join development of innovative technical solutions. This is very important because this is what we're going to talk today, but these are the core for being incorporated in the strategic research and innovation agenda that we'll talk a little bit later, that will incorporate those technologies as part of the solution. How to bring them to the Chinese market and how to make a cooperation 1 + 1 = 3, Europe-China, including also the development of common technologies from China to Europe also. We would like then to have a review of what are the appropriate technology for solving the very urgent water resources problems in China, like droughts, climate variability, change, etc., flooding control, etc. So these are the key basic issues. So summing up, what we would like to do is identify the technology water innovations, but also what is avoiding that we have a larger contact. So the drivers, barriers, and the strategies for overcoming such barriers. This is another work package. Build an enabling environment for the uptake technology water innovation for application in China. Is language a problem? Is the concept of developing business a problem? We don't think so. So we have made a strategic research and innovation agenda that's going to be presented here, and it's already available. And we are intending to have this dissemination issue, and we are going to have, besides those conferences that we had before, also in 15 of May in Brussels, so a conference there for disseminating the achievements of piano, and we will have a similar conference in China also in May. Now, reflecting and focusing a little more about Work Package 2. So we will see Work Package 1 is dealing with the incorporating of the know-how, but I'll talk this a little later. But this is the core of this presentation, Work Package 2, Technological Water Innovations. We would like, and we have done that, to identify and prioritize or rank European technological water innovations that have a potential for application in China, and identify the water challenging in Europe and China that have suitable technologies to offer and enhance opportunities for joint development of those technological solutions. So that's what I was telling you. And the outcome is available in the net, I will show you in a while, a report on European technological water innovation. China has done a similar study. So I was saying before that this catalog is already available. So if you connect to the Piano website, we are able to see where are we going to get this. So project-piano.net, this catalog /2, it's available. So if you click here, you can download it. But of course, you are able also to see different aspects of piano, like as I was saying, what have they done in WP1 that I was saying before. The core is WP2 and WP4, but WP1, networking and communication, and it was assessed by Office International de l'Eau, a large network of cooperation that's already available, and of course we would like to incorporate what is going on and also the good achievements that it was done. Technology water innovation, WP2, we have said, driver barriers and strategies, the SRIA, and that's going to be talked today. And finally, you can have also other topics like the piano survey, but dissemination and exploitation. So this is what we are willing to do. So a lot of this and videos also are available there to see what we are and will be developing. By the way, I'm presenting this today, that's the 6th April 2018. The project will end next month, so 31st May is over. And of course, we are going to be able to fulfill all the contractual aspects. So going back again then to the WP2 Technology Water Innovations. This was divided by the different partners in tasks. So task 1A was for Europe, 1B for China, and 1C it was simultaneously seeing what both sides have done to integrate. Task 1A, it was agriculture water management, ISPRA, Rome was coordinating, and LANEC also, besides Denmark and the European Water Association, were involved. Municipal water management was divided also by ISPRA, coordinated, with Danish, Boku, Austria, Danish Technical Institute, and we are having several. But I'm going to focus most on D and E. So this is the river basin management and flood control, and LANEC was coordinating this with ISPRA, Denmark, European Water Association, and Water for Energy, LANEC again, with Denmark, European Water Association. Of course, you have to incorporate the know-how available. And in Portugal, the Eletricidade Portugal, Portuguese electricity, has been in contact, and they are merging partially with the three gorges in China and developed Center of Excellence in Lisbon and in Shanghai. And so LabLec, that's the research component there, has a strong know-how about water for energy. So LabLec, EDP, Portugal were partners of LANEC developing this stuff. So you see precisely, besides the other two, we added LabLec here too. So we are going to develop how we have to say the reasoning behind the selection of the technology water innovations, and of course also the ranking and the prioritization. As all projects have, we have a very tight schedule. So we had to develop world assessment in our offices, knowing what is the best, what has been done, so assessing gigas of information and reading that. For instance, the database of Eureka, EcoWeb, etc., we have analyzed that. So we have then developed the preliminary selections of thematic areas. It's a huge area, water resources management, flood control. You can see that from several viewpoints. So we were seeing, based on the Chinese documentation by regions and also along the time, what are the research needs and innovation needs. So we have come to 10 major items, like subthematic areas, like you can say climate change impact assessment on China water resources, water scarcity, aquifer risk due to groundwater depletion. So the managed aquifer recharge is a must, and they organize in Beijing an ISMAR conference. The next one is going to be in 2019 in Madrid, organized by Traxa. But this is very interesting, groundwater allocation to adequately regulate groundwater quality and quantity. Okay, so those were the thematics. The Portuguese Partnership on Water, PPA, was part of this questionnaire analysis, and more than 100 members then were able to receive a template. And this template was written by someone like Joaquim de Jesus from Portuguese Original Solutions, identifying one of this technology. This was developed in Portugal, behavior fish barriers using strobe light. So what they were willing to do is to avoid fish in the reservoirs to go in the conduits leading to the turbine. So avoiding the predation of the life there. So this is a type of technology. So this was the first part of the template, 1, 2, 3, but we have up to 10. So we would like to know how is this technology being developed, why is it being developed, so to have reasoning behind this. And of course, we have to know if this technology water innovation is a need or meets the Chinese water challenges. So the idea is to use technologies from Europe to be incorporated there on water resources management, flood control in this case, but also water for energy, that's also this case, and that was one of these technologies that I myself have developed, Hydromax Metrics, Andritz Hydro, and it was receiving a prize from the government or the president of Austria. So these are very interesting opportunities for application further in China. But we are also willing to know how far are these technologies being developed. So the technical readiness level, is this just an idea or is already in the market, is obsolete, WTRL-10, in the Mark 9, etc. So we were willing to develop those types of technologies that are still undergoing and appropriately could be used also in China for development. And of course, we were willing to know if other partners are interested in this, like, of course, the producing area of Portugal, of Spain, Iberdrola, but also others. So trying to see why we think this is an interesting technology to be developed. Based on this type of questionnaires and internet search and conference and telephones and emails, etc., to those institutions dealing with this subject, we were able, according to that 10 item classification, flood protection technology, reactive, or if you would like to prevent, etc. So what are we doing very well in Europe? So this one, it was improved river basin management, include flood risk management using space-based technology and information communication technology. It's an example. Smart dikes and sand engines, sensors that rely real-time and condition of the dike from the Netherlands, etc. Geophysical, electrical resistivity, ground force analysis, optimize solutions for flood control. So we were dealing with several of these techniques to see what is available. And in the contract, we had to select in each one about 20. So we select for this water for agriculture, for instance, 20. The Chinese also do the same. 20 is the minimum, but we could do more, like year 23. We also received to the Danish Hydraulic Institute some kind of questions, but just to say that it was coming late, but nevertheless, we incorporated them. So everything that we received and we developed, it was written there with the coordination. Afterwards, we had to rank this. So to see, are all these technologies in only one of those items? The others are void. So we are trying to distribute among the problems of China the technologies there. So not to concentrate everything in the same item, so to distribute them. So we would like to have different types of classification in an Excel file, trying to see what are the opportunities for development. So we quantified this and we ranked afterwards the sum of all these parameters. And we come to a certain type of analysis. So this ranking task 1D table, okay, we discussed with the partners, and we had also two different types of approaches. So we have ranked in different types of Excel files, and surprisingly or not, we could come to a common sense. So most of them were in the 3 ranking devices. So it makes this selection somehow robust, and we trust them for dissemination. And then we ranked then this, and for instance, flood control, it was the improved river basin management, including flood risk managing using space-based technology. Somehow it's interesting for controlling the flood. The river basin management is a must, so you have to have a very. But the data is also important, and the data on time, online, probably is one of the critical issues. But we have done the same for the preventive, for the reactive or preventive, but also structures, adaptation measures, etc. So we have a large set and ranked of this type, monitoring, etc., devices. Okay, so we have a complete setup. As I was telling you in the beginning, the idea here is to, because it was presented in the Portuguese Water Congress, 14, I think, we were interested also to see the cooperation, have this country done good or not. So we were presenting what we have done, okay? And we have smart tools and smart water, wastewater management operation from Águas de Portugal, some water from Portugal. This is the engineer. Here is also Cláudio de Jesus, Pedro Pova, that have, based on the questionnaire sent by the Portuguese Partnership on Water, answered to us. But we have several. Myself have developed and discovered this also in Portugal. And it's very interesting to see that you have clickable here this description of these technologies. My observatory for rivers was developed with 2 friends for me. It was Nuno Charneca from LENEC, and also Yoram Rubin, that now is in Berkeley in California, and the Portuguese government awarded the prize to this My Observatory for Rivers, a web mobile application to report river water body status. So the citizens are allocated, those volunteers, 500 meters of the stretch of this river to see how is that, and they report later with this application to the water authorities, but also geophysical survey, etc. All together for the river basin management flood control technologies. From the catalog, we can have the following. So it's about 10, because we have developed like 23, you saw, Shine the 2, so we have more, and then we come back to, besides this catalog, to the prioritized 10 best in our opinion. And then it comes to the smart and sand engine for coastal zone erosions from the Netherlands. You have this type of monitoring devices that was developed here in Portugal. Smart Buoy performing in situ water quality monitor and web platform receiving the information provided by the buoy. So trying to see online if it was an accident there, and if you have a water supply from there, you are able to take. But also different types of aspects, very interesting indeed. We have the categories, integrated river basin management tools, flood protection, like this bio-inspired dams for ecosystems degradation management. So how to maintain the ecosystem in a sound, sustainable way. So also for semi-arid regions. Improved river basin management, including flood control. We have the space-based technology that we said it before. So we are in My Observatories for Rivers, 2 microalgal dual head biosensors, flooding technology for water retention and flood resilience. So this is a picture from China. And we have also the natural water retention measures and decision support system tools. So based also in the managed aquifer recharge that will create a storage like capacity, like a water bank. You have the excess of water you plug in there, in the ground, in the aquifers, and in the next years, if it's a drought, you go there to pick up if it's still there. So the modeling is also a crucial aspect. Okay, I'm finalizing then this now. From the next thematic, water for energy, we in LANEC, at LANEC, and with the EDP LabLEC, we have considered different 6 sub-thematic areas. You remember it was 10 in water resources management flood control. Here you have different types, and we went to the revision of what was done before in the, for instance, www.smallhydro.com. They have programs, innovative technologies. So we assess what the others have done too. Energy production technologies, water management technology, mitigation measurement, safety and efficiency of the existing dams and reservoirs. This is very interesting because LANEC is also developing this modeling. We have a large amount of dams in Europe and in China, and they are growing old, so they require maintenance and how to discover where are the vulnerabilities and where is the risk. So we are doing a lot of this type of issues here at LANEC, and we will see later some of these templates. Conservation, new production technologies, etc. So, as I said it before, we had these different thematics, mitigation measures, energy producing technologies, and we were able to get a lot of different types of technologies. As a matter of fact, 22. You remember we had to do 20, and we have done 23, 22. So we have developed this type of different types of approach. And also geothermal, new productions, wave power, so different types of source of electricity. By coincidence, last month, March, Portugal is able to have more than 100%, it means exporting, fulfilling all the requirements with renewable energy. So based on hydropower, based on wind power, based on solar power, it was more than enough what we have installed, and so we were large time we haven't done that, so been able to supply. So it means that it's working. Geothermal also in the Azores, it's very interesting, and in Iceland, of course. So we have characterized this divided by these items, mitigation, safety, and efficiency of the existing dams. And we have ranked based in same Excel sheet and these different types of communication. It's interesting because this comes from a ranking. So you have a lot of different types of interests. Feasibility for China, for instance, you evaluate this. Technology readiness level, you develop this. And it's interesting to see that our rank #1, it was precisely this Hydrometrics from Andrix that received the prize from the President of Austria. So in a way, it means they have given the prize and we have ranked this as one of the best. So it makes our reasoning a little more sound. The Portuguese contribution, as I was saying before, we have here at LANEC the earthquake, so a shaking table with 3 different types of movements, possibly, where we assess the risks of failure of structures as large as this room, that you are able to do that. But besides, we are developing also modeling, and so LANEC also has developed some of these templates, earthquake safety assessment for concrete dams, foundation failure, also the integrated assessment structures modeling of swelling process in concrete dams, also from LANEC, automatic behavior vibration monitoring systems, etc. So this behavioral fish barrier, Aqualitas from this freshwater regional solutions, but we had also from the Portuguese Water Authority, the Water Agency, APAmbiente, the Portuguese Flood Surveys and Warning System, the SNIR written by Rui Rodrigues here at LANEC. The same type of catalog then that we have with those partners involved, as I have presented before, are available there. You can click, you have the internet link here, so you are able to see a little more what is this about. So energy production technology, geothermal energy pump to harvest geothermal energy, etc. So those type of non-pollutant solutions, micro hydro generators. This don't even requires a dam, just a small ditch there, and then you produce electricity and you are not causing problems around that sometimes the environment assessment study is worried about. So we have also those type of clickable internet, the strobo light that I was telling you, but this very low head turbines generator for less than 4.5 meters, then it's the future also. So very low head capacity in canals, in dikes, in small dams, reservoirs, etc. It's now available, and we have put a lot of efforts generating this type of the Kaplan, Pelton, etc. turbines. Okay, this was one the price, but also lubricated bearing, water lubricated bearings that are adapted to the guarantee the non-pollution of the river. So water lubricated bearings technology guarantee the non-polluted of the river. So we were also worried about this type of ecological behavior and what are the dams causing and what is the solution. But also the earthquakes analysis and also the failing or the growing old of the structures, the waves from the sea, etc. And our power and also the refurnishment, the simulator, decision support systems, etc. for this. So this concludes this first part. I was just intending to say that we also participate here at LANEC Teresa Leitão, and we presented by COTRE in Alentejo in Portugal in a side event that the action group from the European Innovation Partnership on Water, to Market, that I'm leading, in the conference in Oporto last year, the European Innovation Partnership on Water large conference. So we had a side event and relating managed aquifer recharge, agriculture, etc. We have contributed to the agriculture water management, and we brought there so the agriculture, the techniques, the engineer that provided us this type of solution, so integrating PIANO and the European Innovation Partnership on Water, okay? So now this was coordinated by ISPRA, so this water manager said before, but ISPRA also was coordinating, and I'm changing now the item, the Policy Uptake and Strategic Research and Innovation Agenda from PIANO, the SRIA. And we presented this, as I told you, a couple of weeks ago in the Portuguese Water Congress in Évora, in Alentejo. Okay, so what is this Strategic Research and Innovation Agenda, and why have we linked both together, the Technology, Water Innovation and Strategic Research Innovation Agenda? Of course, because we'd like to incorporate in this agenda where these technologies are better applicable in China to cope with the developments there and to see how they are part of the solution. If they are not very well developed, you remember the technology readiness level has different categories, so we would like to see where should we say to the European Commission for Horizon 2020, we have just 3 years to go, but still a lot of money available, like 30 billion euros. It was in the beginning of this third phase of Horizon 2020, but we are already reasoning on the next framework program for research, FP9. So this idea, we have said, okay, based in this technology, we and the strategic research agenda, we are suggesting this thematic to be included in a call. This is for research, this is for innovation. That's what we're going to talk later, and that's the connection of both aspects. But of course, we had to see what are the targets of the world, of the United Nations, of the China itself, Europe. We have a framework water directive, China has a document 1, and they are developing very, very, very good resources to overcome those gaps that they had before. Absolutely amazing part of the work done there, and I will refer to you a little later about the sponge city concepts, how to incorporate water in very strong precipitation events that cause floods, making the cities permeable, so you store the water and it's avoiding floods and you have an extra amount of water. And a large amount of cities, as a matter of fact, as a demo site 16, are already by law obliged, forced to do this or suggested to do this, incorporating the know-how available. So the data, the 17 Sustainable Development Goals that was intended to be part of the 2030 Agenda for Sustainable Development are the following, and we were also seeing what they are saying to us to do, what is the requirements, etc. So incorporating the good jobs that have been done by others. And then we divided, again, I'm just showing the ideas of these three, agriculture, water resource management, flood control, and water for energy. We have tried to see in China what is the need. So to know what is need in China, of course, you need to go to the 5-year plans, and this one is ongoing, 16 to 2020, to see what have they identified as a need. So mechanization of agriculture, promotion of innovative technology, etc. So they are saying to us and to the world, we need this, okay? Why? Because they have increased in China fantastic large amounts from 1949, they had 16 million hectares of effective irrigation, and nowadays the 16 moved to 62, so 1/6 to 6/2. And of course, if you are doing this, the excess of water coming from the irrigation, if you have a bad concept of water irrigation with this water, it creates a return from the irrigation drips there to the groundwater, and if they take the pollution, remaining pollution, nitrates or pesticides, it will return then to the surface water, creating pollution problems in surface water. So all this has to be somehow researched, and China, with 21% of the population, has 6% of the total fresh water and just 9% of the world arable land. So the technology has to be incorporated. So the challenges that we had are water scarcity, water pollution, extreme droughts. Based on this challenge, we developed a reasoning of what what should we do? We know the figures, 21% of population, 6% of the water. So water reuse, water saving, it's of course a need there. So listed amongst the main challenges facing Chinese government and implementation of water saving policy and technologies. So this is the basic aspect for the selection of our technology for China. Water pollution also, as I told you before, the return flow from irrigation fields to groundwater and later eventually to the rivers. It's a problem there. I've myself been traveling 2,000 kilometers in Yellow River, seeing all these problems and achievements in 9% from 9 member states, financed by the European Commission. And we have also the drought and floods control monitoring of extreme management events. And this is the output. So this challenge, water scarcity, pollution, etc., we think that, for instance, water-related salt degradation technology, salinity, erosion, degradation, clogging, oxidation, is still needing to have research, innovation, action, and innovation action. So a call for proposals. We suggest that we incorporate this thematic in the next call for proposals, the European Commission. Please, European Commission, consider this as one criteria or one topic that needs. This one, we think that we have around already very good research. So we need to put this research into practice through the SMEs also and the actors. So what is needed here is, of course, small appropriate research, but innovation, putting this research available into the ground to do the job, creating jobs and overcoming the problems. So this is what we have done, and also linking what I told you before with the technologies for technology water innovation in the past. Those are part of the solution to overcome those problems. It's just an example, those three, because you know the catalog has others, a large more amount of them. But the decision support systems, the software for nitrogen budgeting, for the crop base, etc., we have this type of know-how, say, please do use it. This is innovation. You can pass this research that's already done to the field. Use this, please. So this is from the river basin and management control. That's what I was telling you in 2013, the Chinese central government called for the widespread adoption of the sponge city approach, providing funds for pilot activities in 2016. So this is where we should also learn Europe. So humble enough to go there and to learn and apply it here also. So this is what we are doing in Lisbon. We are creating small dams also inside city and trying to get this water not in the city but incorporating in groundwater. So we are already doing, but not as this as a must. We are already too much considered of the problem of pollution and not yet enough as scarcity in the Mediterranean area. So I think this is a fantastic way to do also this type of approach, connecting, learning also from China. So we have this type of challenges, okay, from we have included ecosystem degradation. Now we are in river basin management and flood control. And of course we have the decision support system. Water scarcity will be reduced using this type of approach. So we are willing to see through new remote sensing technologies such as Doppler radar and wireless sensors. Cityness observatories for water management is also one of the possibilities to avoid flood protection, but to avoid floods, and the flood protection, reactive and preventive, it's one of the issues that we saw before. Of course, our target was then also to have this RIA and IA, and one of those we said is precise and water aquifer recharge technology. So we are having now in the Mediterranean area also, based on wastewater, a call is just this month of April, launch. So in Europe, based on the monies of the European Union in connection with Horizon 2020, we are also dealing with this, but just not enough. So this project just 2 million and probably should be larger. Monitoring system to assess groundwater abstraction and recharge, main aquifer recharge technologies, but also research at catchment scale. Okay, so all the pollution, contaminated areas remediation. So we say we need this type of issues, water challenge, ecosystem. So this is a contribution and to the next calls, but also relating then these technologies that we have said before and trying to have this type of approach going on. So finalizing the water for energy, we have this type of approach too. So the hydropower and the plate, and we have a large amount of other power accounting to almost 1,000 terawatts hour, 7% of the production in China is hydropower. So we are willing to increase this by those types of technology, and also the water energy nexus, energy is needed for water supply, etc., creating. So this suggestion for the call, and this again is the relation of this SRIA with the technologies that we had before mitigating. So the steps to achieve this are, of course, related to China-Europe Water Platform, those conference, and trying to get involved more with the local authorities, regional authorities in Europe, and also the government, central government, regional government in China, trying to make awareness of all this capacity, engaging the public, the private partnerships, etc. We have a large amount of cooperation, and the idea is to offering opportunities to exploit synergies, okay? Creating synergy, 1 + 1 = 3 if you create the synergies, and of course we are facing the priority areas that the documents from China, document 1, the assessments, and of course Europe has. So this is SRIA, and here is the book that is ready now. We have been developed and that will be presented. We have discussed this with the European Commission and also with the China-Europe Water Platform, so it's ready. I would like to thank you for being listening to this web streaming. It's part of the web stream that ISPRA is putting together with those 10 European partners, besides the workshops there. And I would like to thank to our Portuguese partners, LANEC, that supplied extra money for fulfilling the jobs. It was a little short from the side of the project itself, but LANEC contributed to that. To LabLec, ADP also the same. They put the money for us to have this survey in water for energy. And of course, our colleagues here at LANEC, Dr. Teresa Leitão, Luís Lama, José Falcão de Melo, Rogério Mota, Rui Rodrigues, Nuno Charneca, and the PPA, Joaquim de Jesus, Freshwater, Cláudio de Jesus, Pedro Pova. So a lot of people have been contributing to us, the PPA, the Portuguese partnership too. So thank you for being here. It was a pleasure to disseminate this to you. And thank you, obrigado, grazie tante.